Camp Grayling, the largest Army National Guard training facility in North America, covers roughly 147,000 acres across multiple counties and has played host to Allied and Reserve forces from across the U.S. and abroad, making Camp Grayling a cornerstone of national readiness and joint training efforts. These training operations have also left a legacy of PFAS impacting the soil and groundwater on base and requiring remedial efforts to avoid contaminant impacts from moving off-site into the Grayling community's water sources.
The community's been very involved in this process from the very beginning, and Michigan Army National Guard and the Federal Army National Guard have made a serious effort to keep them informed about what's going on. Because of the location, there's a residential community directly downgradient of the site, and the issue is PFAS in the groundwater.
We're looking to interrupt that plume in between the source area in those private receptors downgradient and do whatever we can before it further affects them.
To keep PFAS contaminants from moving off-site, Army National Guard engaged the U.S. Army Corps of Engineers, AECOM, and Regenesis to design and install a cost-effective soil and groundwater treatment system that captures PFAS underground.
AECOM's been involved since about 2017. We started the remedial investigation work in 2019, and that's been ongoing. That has led to the U.S. Corps of Engineers and the Army National Guard to move forward with some work to try and mitigate this PFAS issue out here.
Regenesis has been communicating with us and with Army National Guard on the federal level and AECOM so that Regenesis understands the technical aspects of this site, what the geology looks like, what the groundwater looks like.
The team spent significant time designing the barrier and characterizing the subsurface to ensure the material would be placed efficiently and uniformly. Using that design, PlumeStop was injected at multiple depths, from roughly 50 feet below ground up to the water table, creating a continuous treatment zone that fully intercepts the PFAS pathway.
Doing these barrier configurations allows the groundwater to passively flow through the treated area. So in essence, what we're trying to do is set up a filter within the aquifer to pull out the dissolved phase PFAS contaminants.
Instead of employing a traditional pump and treat system that pumps water to the surface for treatment, this approach uses colloidal activated carbon injected directly into the subsurface, providing continuous long-term protection and generating zero PFAS waste.
Remediation, in essence, is to remove the risk or the potential of that risk to the receptors. If you can remove the exposure pathway, the risk is no longer there. The alternative is a very energy-intensive process, so you'd have to physically remove the water, run it through separation technologies, and then do something with the waste. This is a great tool for many project sites that want to be effective at reducing the risk, but also in a cost-effective and environmental-friendly way.
A key component to the injection event incorporated the IBIS inline blending and injection system. IBIS precisely applies PlumeStop and controls flow and pressure at each depth interval. This level of control improves consistency in the field and speeds up the overall installation.
One of the benefits of IBIS on this site is that it's going to help us track data more effectively at each discrete interval, which will allow us to get a better understanding of how the lithology reacts to the treatment. With the technologies that we're using and how they work in conjunction with the contaminant, it's paramount that it covers every inch of that treatment interval.
Now that the barrier is in place, groundwater will continue to flow naturally through it. PFAS will be captured by the PlumeStop instead of moving down gradient toward private wells.
I found working with Regenesis to be great. They're very communicative and technically astute.
Here at Regenesis, it's very satisfying to see a project move forward like this and to know that we are protecting against downgradient receptors like the town of Grayling and their water supply. I'm very pleased that the Department of Defense and Army Corps and Air National Guard and everybody involved is moving forward with this type of treatment here.
By combining precise design, advanced materials, and strong teamwork, Camp Grayling and the Army National Guard are setting a standard across the U.S. for how PFAS can be effectively treated in groundwater, protecting communities like Grayling now and into the future.
It does mean a lot to be in this line of work and setting that example of being a good steward of the environment.
Regenesis has been great to work with. I think we have a great team. We all recognize we're in this together, and we're all trying to find a solution at the end of the day to protect human health.
For more information on PlumeStop and PFAS treatment, visit www.regenesis.com.